You're talking about scientists. Well, I have one with me, Pallav Bagla, our science editor, someone who tracks space perhaps. I think that's one of your biggest interests, Pallav. And you track science generally, but space is something that's special to you.
That is true.
From a scientific standpoint, what makes this eclipse so special?
Eclipses happen every 18 months. See, when the corona can be seen, when the sun is hidden by the main sun is hidden by the moon, and you can see the large gaseous mass around it, which is never seen otherwise. That is what makes eclipses very interesting for scientists. That is when they can study what is happening in the corona, which is the gaseous mass surrounding the sun, which is not seen otherwise because the sun itself is so bright. So
and tell us a little bit about that gaseous mass. What makes that at once the most dangerous part of the sun in terms of the gases coming out, but also from a scientific standpoint, some of the most interesting aspects of the sun which need to be studied?
See, we understand so little of the sun. It is the main energy source for our solar system. If there were no sun, there would be literally no life, no existence on our solar system, on Earth at least, definitely. But the energy which is generated in the sun is because of fusion. Hydrogen and hydrogen, two elements, those atoms are fusing with each other at high temperature, and the energy is being released. That fusion energy is what is interesting for people to understand. And how and why, what happens to the various elements, the plasma there, how it is interacting, is what makes the corona very interesting.
The ultimate nuclear power plant.
Nuclear power plant,
in a sense, our sun.
Right.
But as far as the eclipse itself is concerned, it's already, well, it's not quite started now. It's about 5:14 or so by my, 5:15 I'm told. 5:28 over the Indian Ocean is when it starts, right?
That is correct.
And Pallav, just explain to us, why is it that, that people would necessarily not be able to see the entire eclipse across that band?
See, across that band, there is a 280-kilometer band where you'd be able to see the totality of the phase. The first phase begins where the shadow of the moon touches the earth, and it crosses there. That's the beginning of the phase. And then you have the slowly creeping over, then it comes over the entire surface of the moon, and it's kind of covers it totally, and then it goes across. This whole thing takes long. The most interesting phase is when the entire disk of the sun is covered, which is called the totality. That is about 3 minutes in India, 3 minutes plus
Pallav,
or minus.
It'll look something like this behind us. I mean, if we can just cut to...
This is how exactly it will look like. And sometimes you see that little diamond ring where you see a shining object next to it, which looks like a diamond.
And this image that we have, this rendition, it's not a complete solar eclipse because the sun is still partially visible. A complete eclipse would be when you just see that external halo. Is that right?
What you saw there was that little diamond ring.
Right.
See, when the sun is just finally going behind it, you see that little ray of light, that extra light which is coming out, which makes it look like as if you have a diamond. There's a ring around it, and that little spot is looking like a diamond. That's why it's called a diamond ring. And then comes the Bailey's beads.
And there are dangers of in looking at the complete eclipse, aren't there?
See, in the totality phase, when it's totally covered, you can definitely look at it.
Tuba.com